This video is a continuation of Chapter 1, and we will discuss the topic of the routing table. Some of the things that we will discuss are the structure of the routing table, how we get routes into that routing table, and how we can modify those routes. There are three routing principles to keep in mind when we are talking about routing and taking a look at the routing table. The first principle is every router makes its decision alone based on the information it has in its own routing table. We cannot take a look at anybody else's routing table. We can only take a look at the routing table that we have in our own router. So we cannot make any judgments or assumptions on what other routers have. The second principle, the fact that one router has certain information in its routing table does not mean that other routers have the same information. So again, we cannot assume that just because we can get to a destination that our neighbor router can get to that same destination. If we have a route to the destination, it does not mean that any other routers have routes to that destination. We cannot assume that. Principle 3 is routing information about a path from one network to another does not provide routing information about the reverse or return path. Just because your computer or router can get to a certain destination does not mean that that destination can return packets to you. It's not a two-way street. Routing is a one-way street. The routing table. In order for a router to send packets to the correct destination, a route must exist in the routing table. And we're going to discuss three types of routes and three ways we can put routes into the routing table. The first is directly connected, static, and also dynamic. Directly connected routes. These are the easiest ones to install. Directly connected routes are routes to networks that are directly attached to a router. Directly connected networks get put into the routing table automatically when an interface is configured with an IP address and a subnet mask, and that interface must also be turned on. So when you configure an interface on your fast Ethernet and you turn it on, that directly connected network now gets put into the routing table. Here's an example, taking a look at this from R1's perspective. They assigned the fast Ethernet an address of 192.168.1.1, and they turned on that interface. That automatically put in this directly connected network of 192.168.1.0, because the 1.1 is on the 1.0 network, and it's directly connected to the fast Ethernet 0/0. If I were to turn off this interface, this directly connected network would go away. Again, the interfaces must be turned on. It also has a second directly connected route that is the 192.168.2.0. They assign the serial 0/0/0 an IP address of 192.168.2.1, turned it on, and that automatically put this route into the routing table. This here is the basic structure of the routing table. We will first see a letter, and that letter will dictate what type of route it is. Is it a connected route, a static route? Did we learn it through IGRP or RIP? That first letter is just an indicator again of how that route came about in our network, in our routing table. The next part that we're going to see is the network and the subnet mask. This is the network that we can get to. So we can get to any destination on the 192.168.1.0 network. The second part is going to be how we get to that network. It may say that it's either directly connected, or it may give us a direct or a next hop address where we would send that packet next. In this situation, it's saying it's directly connected to the fast Ethernet. But again, what we're seeing is the networks that we have access to, that we can connect to, that we can forward packets to. Static routes are the second way in which we can add routes to our network. Static routes can be configured one of two ways. We can configure a static route with an exit interface. Static routes are good for small, unchanging networks, and they are considered more secure. This here is an example of a static route. You would have to go to the global configuration of your router and type in IP route 192.168.1.0, the subnet mask, which in this case is 222.55.0, and then how do we get to that 192.168.1.0 network? Well, this is an outgoing interface. So for this particular router to get to the 192.168.1.0 network, they will send those packets out to the serial 0/1/0. Static routes using the exit interface, they are considered more efficient because the routing table does not have to do or perform what's called a recursive lookup, which it does for the next hop address. And I'll talk about a recursive lookup here in just a second. The second way in which you can configure a static route is by using a next hop address. So instead of telling the router exactly what interface to send out, you tell it what the next hop address is or what router to send that packet to next. Here's an example. We type in IP route 192.168.10 222.55.0 and then the next hop address or the next router that we need to send to get packets to the 192.168.10 network. Both of these routes will work just fine. They will both get us to the 192.168.10 network, but it's just a matter of how efficient we want to be. Do we want to go next hop address or do we want to go exit interface? As I said, if we use the exit interface, it saves us a step and makes it more efficient because we do not have to do what's called the recursive route lookup. We do have to do the recursive route lookup if we are using the next hop. This occurs when the router has to perform multiple lookups in the routing table before forwarding a packet. A static route that forwards all packets to the next hop IP address goes through the following process. The router first must match the static route's destination IP address with the next hop address. Then the next hop address is then matched to an exit interface. This is why an exit interface static route is considered more efficient. Again, basically what has to happen is when you're using a next hop address, we must figure what network that next hop address is on, what interface is associated with that next network, and then forward it out that particular interface. Whereas when we use an exit interface, there is no reason to look up which network is associated with, which interfaces it's associated with. We already know that because we specify that exit interface in the actual command. Existing static routes cannot be modified. You cannot modify an existing static route. Instead, what you must do is you must delete the old static route by placing no in front of it, and then you must create a new static route. Here's an example. On router 1, we're in global configuration. We want to get rid of a route, so we type no IP route 172.16.10 subnet mask and then the next hop address. At this point in time, after you hit enter, this router could no longer get to the 172.16.10 network. Here they enter in a new route, and this new route they use an exit interface. This second one down here, they remove the next hop static route and they replace it with an exit interface static route. A couple of special types of static routes are available. There are summary routes and there's also a default route. Talk about a summary route here first. A summary route reduces the size of the routing table. And route summarization is just the process of combining a number of those static routes into a single static route. If you take a look at this first diagram over here, we have the networks in a routing table of 172.16.10, 172.16.20, and 172.16.30. Notice the S's, that means that they're static routes. We manually entered them, and they're all directly connected routes on our serial 0/0/1. So this router can get to the 10, the 20, and the 30 network. We can take all three of those networks and we can combine those into just one summary route, condensing the size of the routing table and making it a little bit easier to read. What they do is they combine all three of these into the 172.16.00 network. All of those are directly connected to the serial 0/0/1. On the right hand side here, it's just showing that the pings to those different networks would indeed still work. We will learn how to do this this semester, but just to introduce it now, it's called route summarization. The second type of special static route is a default static route, or gateway of last resort it's sometimes called. This is a route that will match all packets. Stub routers that have a number of static routes all exiting the same interface are good candidates for this default route, such as connecting to an ISP, Internet Service Provider. Configuring a default static route is very similar to configuring a regular static route, except for the fact that we use the quad 0 format. So we do an IP route quad 0 space quad 0, then either an exit interface or an IP address. Since we're using the quad 0, any packet that is destined for this router will meet this criteria, will meet this route, and it will use this to forward packets. One thing to note, though, is that routers will always use the most specific match. So if there is a specific match in the routing table, it will use that route before it will use the default static route. But if there are no routes available, no specific matches, it will use this default static route instead of dropping that particular packet. A third way in which we can get routes into the routing table is dynamic routing. Dynamic routing protocols can be used to automatically enter routes into the routing table. Dynamic routing protocols are good for large changing networks. They are considered a little less secure because packets need to be exchanged between routers that have information about their directly connected networks, that have information about those particular routers. Because those packets could be sniffed or intercepted, it is considered less secure. There are many different types of dynamic routing protocols out there. RIP, IGRP, EIGRP, OSPF, ISIS, and BGP are a few. The ones we will learn about in this class are RIP version 1 and version 2, EIGRP, and OSPF. That is all for this particular video. Again, this video is just to introduce routing and how we can get routes into the routing table. All of the topics that I discussed in this video we will come back to and spend a lot more detail and a lot more time on. It was just to get some of the terms out there, get you thinking about the routing table and how we can get some of the routes into that routing table. Again, don't be too concerned with specifics at this point. We will spend a lot more time and a lot more detail in future chapters. Thanks for watching.